You may find it necessary to reposition or remove the fan countershaft assembly to help in removing the pulley assembly. Loosen the main drive belts. Remove the bolt that secures the clutch tube weldment to the clutch arm casting. Remove the two 5/16" bolts that secure the rod ends to the idler pulley arm. Caution: during the construction of the helicopter and final installation of these bolts, the builder was instructed to use Loctite thread locker on the bolts. It is likely the rod ends have also become locked to the bolt grip area. When backing the bolts out, be sure the rod ends are not pulling away from the pulley assembly with the bolt. If the rod ends pull away from the pulley as you are backing out the bolts, damage from stress bending of the weldment will occur. Remove the clutch tube weldment. Remove the pulley mounting arm bolt, part number E00-2522. Remove the assembly from the helicopter. Check the end play of the rod ends of the clutch tube weldment and the bolts in the idler pulley assembly. The clutch tube weldment springs and piston need to be inspected and greased at the 100-hour service interval. Before removing the rivets, inspect for wear of the piston on the top and bottom by moving the rod end up and down. Look for excessive play. Replace the piston if necessary. Remove the pop rivets on the end of the clutch spring tube. Remove the tube piston and springs. Make a visual inspection for wear. Check the condition of the springs. Grease the springs, piston, and clutch spring tube. Install the two pop rivets while compressing the piston a slight amount. Inspect and clean the idler pulley assembly. Clean the bolt hole of the idler pulley arm with a Q-tip and acetone. Clean the threaded bolt holes. Reinstall the assembly back into the helicopter. Place a thin film of grease on the bolt and mating surfaces. Reinstall the bolt and replace the 5/16" nut. Tighten the nut enough to allow the pulley arm weldment to pivot. Reinstall the clutch tube weldment to the idler pulley arm. Use Loctite removable thread locker on the bolts. Install the piston rod end to the casting and check the idler pulley engagement. Retension the main drive belts and check the operation of the idler pulley as shown earlier in the maintenance video series. Check the security and condition of the torque link and its components. If necessary, remove the torque link from the helicopter for a closer inspection. The RI-162F engine is equipped with Rotorway's FADEC electronic fuel injection system. In this system, gasoline is delivered to the injectors at a very high pressure, up to 60 psi. Braided stainless steel hoses and high-quality fittings are used throughout the system. Check routing and security of all hoses. Inspect all hoses and fittings for leaks. Run your finger under each connection to verify that fuel is not leaking out. Caution, Teflon-lined steel braided hoses have a tendency to set after being exposed to heat and pressure. Attempting to change the curvature of a hose after it has set may cause the lining to crack. After performing any maintenance that requires hoses or fittings to be uncoupled, perform a pressurized leak check. To do this, tighten all fittings, turn on the fuel pumps, and check carefully for leaks. Caution, the fuel system operates at a very high pressure. When performing this check, wear eye protection and have a fire extinguisher at hand. Check the system regularly in the first few hours of operation after any repair. Refer to the engine manual for further details. Remember, every 25 hours of operation, check the pre-filter for any particles or debris that may have washed out of the fuel tanks. However, if there is a large amount of debris trapped in the filter, this would be an indication that more frequent service is required. Replace and reseat the inner O-ring every time the assembly is opened for inspection. Use petroleum jelly to reassemble a shutoff valve filter. At the 500-hour service interval, you will be shown the disassembly and cleaning of the entire fuel shutoff valve filter assembly. The fuel tank caps are vented. If the vent becomes stuck or plugged, the engine may be starved for fuel and the fuel tanks may partially collapse. Remove the cap and inspect the plastic valve on the underside of the cap. To restore venting, heat a piece of welding rod or wire and push it through the valve. The fan drive system is a series of pulleys and belts providing the proper speed reduction for the fan design. Since the fan drive countershaft was removed for idler pulley service, check the condition of the bearings of the fan countershaft drive assembly. Reinstall the assembly back on the frame. Rotorway International has two designs of the hub fan pulley. One style fits between two snap rings, and Loctite 609 is used to secure the bearing to the shaft. The latest design uses a hub with two set screws. Loctite 609 is also used to secure the bearing to the shaft. Verify and inspect the fan's hub bearing is secured to the lower secondary shaft. With the tail rotor belts loose and the fan countershaft belt loose, check for any side play. If you find the bearing is loose on the shaft, chances are your secondary shaft has been damaged and will need to be replaced. Any repairs made to the secondary must be made at Rotorway's Service Center. Do not attempt to disassemble the secondary. Call Rotorway's customer service for more information. Check the high temp fan for stress cracks on blades. Do not confuse stress cracks with excessive resin cracks. Stress cracks will penetrate the fiberglass, and resin cracks will be on the surface only. Check the condition of the fan drive belts and retension them. Note, these belts need to be fairly tight to prevent slipping. The electrical system of the Exec 162F requires little maintenance if inspected properly. The three most common problems are corrosion, vibration of connectors, and chafing of wires. Replace the battery every 2 years or when it will not take or hold a charge. Check the acid level periodically to ensure battery plates are covered. Keep terminal posts clean and free from corrosion and dirt. To prevent corrosion, use dielectric grease or corrosion spray inhibitors on the terminals and connectors. The digital display monitor and engine control unit are not user serviceable. Refer to the engine manual for information on these parts. If these components malfunction, contact Rotorway customer service. Rotorway has 2 generations of FADEC control systems for the Exec 162F helicopter. Be familiar with your system by referring to the engine manual that came with your helicopter kit. On earlier FADEC systems, an assembly of relays and fuses was installed on the back of the pilot's seat inspection panel. Inspect all of the fuse holders for corrosion. Inspect the security of the plugs, wires, and connections. Do not attempt to unplug or disconnect the relay assemblies. If you suspect a problem with any of the relays, call Rotorway customer service for more information. Inspect the FADEC wiring harness for security and corrosion. The fuse holders on the overhead switch panel and throughout the wiring harness can develop corrosion, resulting in poor connections. Remove each and every fuse from the holder and make a visual inspection. If corrosion is found, clean or replace the fuse holder and fuse. Check the toggle switch by first disconnecting the power leads from the battery terminals. The switch should have a good solid snap action in both directions. If in doubt, check the switch with an ohm meter. Check the heavy gauge battery cable eyelets on both ends for corrosion and clean as necessary. Poor contact will cause excessive heat buildup and could result in hard starting. Note, the terminal on this battery shows evidence of heat buildup from a poor connection. Verify the lugs in the battery are tight. Check the quick disconnect connectors on the starter relay for corrosion and poor connections. Check relay by unplugging the quick disconnect terminal that goes to the starter solenoid and activate the starter button. The relay should have a small clicking action. Be sure the battery is connected and the key switch is on. If the relay chatters, check the voltage going to the relay. Voltage should be a strong 12 volts from the battery. check to see if the relay is properly grounded. If a problem still exists, replace the starter relay. Check the condition and security of all the FADEC connectors. Check that all wires are secured away from moving parts and that no wires are chafing against other components. Plugs, pins, wires, and other components may be replaced individually if necessary. However, do not attempt to repair or change any of the FADEC connectors as special tools are required. Contact Rotorway customer service for further information. To check the voltage regulator for normal operation, monitor the voltage meter or select the battery voltage on the digital display during the run-up. If the regulator is working, a voltage jump will be noticed on the meter and the digital display during the run-up procedure. If the meter does not show a positive voltage charge, check the following. Alternator switch is on, voltmeter is working. Check the tension of the water pump alternator belt. Check the grounding of the alternator to the frame. Make sure there is good electrical contact between the mounting bracket and the alternator. Check the fuses located in line of the wiring harness near the alternator. There are 2 fuses located on the output side or field side of the alternator. If all of the procedures above are determined to be in normal operating condition, replace the voltage regulator. If a problem still continues, it is possible the alternator is defective. Check the alternator output with the helicopter in full operating condition and with the alternator switch on. The output should be 13.5 to 15.0 volts with a 16-volt maximum. If proper output cannot be achieved, the alternator will need to be removed for repair or replacement. Note, this alternator is reworked at the factory to achieve Rotorway International specifications and requirements. Replace only with an alternator from Rotorway's parts department. Instrumentation on the Exec 162F is normally maintenance-free. It is, however, extremely important to keep it in perfect operating condition. The instrumentation provides the pilot continuous information on all the helicopter systems. All items are on condition recommended change-out. The ground handling wheels for the Exec 162F were designed for the sole purpose of ground handling the helicopter when the rotors are not turning. This system allows you to handle the helicopter on asphalt, concrete, and grass. Inspect the ground handling assembly for cracks, especially around the weld areas. Refer to the tire sidewall for proper inflation information. Do not leave the ground handling wheels in direct sunlight. The air inside the tires will expand and blow out the tire. If handling over rough ground, reduce tire pressure to help absorb the shock being transmitted to the rotor system. Tire track is important for maintaining longevity of the rear landing gear. If the tires track outward, this will put abnormal stress on the landing gear, which can result in landing gear failure. Check tracking every 500 hours. At no time ground handle the helicopter fully grossed out or with anyone in the cabin. Never ground handle with the ballast weight in the solo position. The ballast weight and ballast weight transport system was designed to keep the helicopter within its operating limitations during solo and dual flight configurations. For proper location of the ballast weight, refer to the flight manual. All weldments should be inspected thoroughly. Caution: if a weldment fails and causes the ballast weight to depart from the ship during flight, the weight and balance of the helicopter could move outside the operating limitations. The choice of paint is left up to the owner-builder of the helicopter. Any maintenance required should follow the paint manufacturer's recommendations. The body panels on the helicopter are manufactured with a gel coat finish. We recommend the use of a two-part paint that will give you years of trouble-free and very low maintenance. Note, the lighter the color of the paint used, the less heat will be absorbed into the cabin and engine compartment, resulting in a cooler operating condition. The shades we find best are light colors such as white, light blue, and tan. The Exec 162F can be operated with the doors either on or off, depending upon the weather and pilot's discretion. Check bolts part number E002300, E00-2302, and E00-2304 for tightness. Caution: if the doors were to come off in flight, serious damage could occur to the helicopter. The main rotor blades are one of the key components of the helicopter. Proper maintenance and care of the main rotor blades will increase their longevity. The main rotor blades are made from aluminum alloys and are constructed from three pieces: the main spar, C-section, and an upper and lower aluminum skin. The spar is an aluminum alloy extrusion with a series of various heat treatments. The skins are of T6 aluminum and are bonded to the spar with a high-strength adhesive, then riveted. It is important to keep this bolt torqued to 60 to 70 foot-pounds. After the nut has been removed 4 or more times, it should be replaced with a new nut, part number E00-3800. Torque to specifications. Before removing the rotor blades, mark the pitch links with a marker pen. This will ensure they will be installed exactly the way they were removed. Mark the pitch links indicating which blade, master or slave, they attach to, and also the up position. The liner block bearing is 100-hour changeout. 2 bearings part number E20-1220 are included with a 100-hour service kit. However, the RCO of this bearing can be increased to 200 hours using a simple tool as shown in this drawing located in the maintenance manual. This tool will enable you to grease the bearings with the blades removed and the liner blocks in place on the blade straps. By leaving the liner blocks in place, it is not necessary to perform the lead lag adjustments when you reinstall the main rotor blades. Insert the tool into the bearing. Pump the grease until the grease visibly comes out of the bearing, purging out the old grease. Rotate the inner race of the bearing to spread the new grease. Then wipe away the excess grease. Important, check and verify the bearing turns freely. If it does not, the bearing must be replaced. If you need to replace the aligner block bearing, proceed as follows. Remove the aligner block bolts, part number E00-2523. Loosen the adjustment bolts, part number E00-2417, 2 to 3 turns counterclockwise, and remove the aligner block assembly. The reason you do not back out the bolt all the way is because the bolt end threads may be compressed or have a burr that could damage the aluminum block threads. Slowly back out the bolts until you feel a slight resistance, then place the block in an oven and heat to 225 to 250 degrees Fahrenheit. Caution, do not exceed 300 degrees Fahrenheit. Check the oven temperature with a calibrated thermometer. Place on a press and using a socket of the appropriate size, press out the bearing with light pressure. Clean the bearing hole in the aligner block with acetone. Clean the new bearing with acetone and prepare to reinstall the bearing into the aligner block. Before installing the new bearing, check the condition of the all-thread bolts. If you determine either of these bolts require replacement before the RCO time of the aligner block assembly, follow these procedures. Clamp the aligner block in a vise using wood shims to prevent damage to the block. Use a small die grinder or a high-speed sanding disc to grind the tip of the all-thread bolt completely off, about 1/4 inch from the tip. Dressing up the threads with a good file or sandpaper, back the all-thread bolt completely out of the aligner block. Some friction will be felt. However, if the pressure is too great, damage to the aluminum block and threads will occur. Blow out the hole with air. Install the new all-thread bolt, part number E002417, with a light film of grease. If you feel some friction when installing the new bolt, try running a tap through the hole. Use plenty of thread cutting oil. Note, use caution, as the thread wall is very thin on this side of the block. Place a small amount of Loctite 609 on the outer race of the new bearing with a Q-tip. Heat the block with an oven and press the bearing into the block with light pressure, leaving the bearing protruding 50 thousandths from the face of the block. Use a piece of 50 thousandths aluminum with a hole cut oversized for the bearing as a thickness gauge. Check the all-thread bolt for clearance of the bearing. Let the block assembly air cool, never quench with water. Pump a small amount of grease using the tool shown earlier into the new bearing and make sure the bearing turns freely. Check the lead lag pin on the root end of the main rotor blades. If this pin is deformed and shows signs of the lead lag bolts being over-torqued, contact the factory for further information. Reinstall the aligner block on the blade according to the directions in the construction manual or construction video regarding rigging main rotor blades. Note, after the liner block bolts, part number E00-2523 have been loosened and retorqued 3 times, they must be replaced. The torque requirement on these bolts is 20 to 22 foot-pounds. Check the torque of the blade strap bolts. They should be 12 to 14 foot-pounds. Do not reinstall the blades at this time. The rotor hub system is comprised of 3 sub-assemblies: the rotor hub assembly, the swash plate, and main shaft. It comes from the factory as a completed assembly. To have a smooth running and normal component life rotor system will depend directly on how well the builder sets up and maintains the system. At every 100 hours, a thorough inspection of the rotor system is required. We will begin with the thrust blocks. The thrust block alignment bearing is a 100-hour changeout. These new bearings are included in the 100-hour service kit. Remove the elastomeric bearing, thrust block liner, and the dust cap. Use a marker on elastomeric bearings to note M for master and S for slave to make sure the same bearing goes into the corresponding thrust block. Inspect the elastomeric bearing, part number E20-1400 and 1401, for signs of delamination or separation. The elastomeric bearings in the rotor hub are comprised of thin layers of rubber and metal sandwiched together. It is normal for some rubber residue to be present on the edge of the elastomeric bearing. However, if you notice delamination of the bearing or you question the condition of the bearing, contact Rotorway customer service. These bearings must be inspected every 100 hours and replaced at 1,000 hours or on condition. Many factors determine how long they will last, such as age, number of hours used, climate, etc. The elastomeric bearing must be kept dry and free from grease, oil, and solvents. Replacement of thrust block alignment bearings are as follows. Heat the block to 250 degrees and press the old bearing out of the thrust block with a press. Note, this is a very tight fit. Very important, use care not to move the steel insert. Use a steel bushing as shown to support the shoulder of the steel insert. If the steel insert moves, it may affect the alignment of the 9/16" bolt hole, thus making it difficult, if not impossible, to install the bolt. Clean the area where the bearing makes contact with the thrust block and reheat the block to 250 degrees. Lightly coat the new bearing with Loctite 609. After the block has been heated to 250 degrees, remove the block and lightly coat the inside wall of the steel insert. Support the steel insert with a socket that is slightly smaller than the outside diameter of the steel insert as shown. Press the new bearing, part number E49-1340, into the thrust block until it is even with the thrust block steel insert. Make sure the numbers on the end of the bearing are facing out. Let air cool and replace the dust cap, liner, and elastomeric bearings. Caution, make sure all parts are reassembled in their original orientation. The outboard and inboard pitch pins are 100-hour change-out items. These parts are included in a 100-hour service parts kit. Removal of inboard and outboard pitch pins are as follows. Remove these bolts, part number E00-2422 and part number E00-2424. Note the inboard pitch pin lock bolt is slightly longer than the outboard bolt. Grasp outboard pitch pin with a pair of pliers and a soft cloth to prevent damaging the outer surface of the pin. Pull directly outward, removing the pin from the hub. Tip the hub so it is at a 30-degree angle to the main shaft. As you tip the hub, position the rubber shaft protector to prevent the pitch pins or hub from contacting the shaft. Install a piece of plastic tubing over the 1/4-inch shaft at the long punch as shown. This will help prevent scoring or nicking in the inside of the pitch pin holes. Now lightly tap the inboard pitch pin out. Use caution and try to avoid tapping the thrust washer out at the same time. If the washer does come out, clean all mating surfaces with acetone and coat with Loctite 609 and put the thrust washer back in place. It may be necessary to tap with a mallet to ensure seating. Before installing the new pins, ensure the holes in the hub are clean and free from dirt and grit. Lightly lubricate the pitch pins with anti-seize and insert the inboard pitch pin into the inboard hub hole. Keeping the flat of the pin upward, tap the pin with a plastic mallet to seat the pin in the hole. Then use a large C-clamp with pieces of plastic to protect the hub surface to press the pin in the hole. The pin should be inserted to 785 thousandths of an inch, plus or minus 5 thousandths. Use the old bearing from the thrust block as a guide. Reinstall the bolt, part number E00-2424, and tighten slowly to make sure the pitch pin's flat spot is perpendicular to the bolt. Tighten the jam nut securely. Reinsert the outboard pin, but hold a tolerance of 750 thousandths, plus or minus 5 thousandths of an inch, from the outboard edge of the hub. Use an old aligner block bearing as a guide. Tighten the bolt slowly, part number E00-2422, and lock the jam nut. Recheck the measurements. Inboard pitch pin 785 thousandths plus or minus 5 thousandths. Outboard pitch pin 750 thousandths plus or minus 5 thousandths. Although the hub plate appears to be a very substantial and solid part, it can be damaged. Caution should be taken to prevent gouges, nicks, and deep scratches to the hub plate. The Delrin shims and stainless steel shims are on-condition items and must be inspected every 100 hours. You will also need to check the hub alignment every 100 hours. The tolerance for hub alignment is 1/1000th of an inch total indicator reading. This check will be demonstrated later in this tape. If the alignment falls within the prescribed limits and the shims are in good condition, it is not necessary to replace the shims. The shims can be inspected while performing service on the main rotor drive pin. The main rotor drive pin must be removed and inspected carefully for grooves caused by contact with the stainless steel shims every 100-hour inspection. The Exec 162F rotor system will require hub shimming at different intervals depending on how smoothly you keep the rotor system adjusted. The 100-hour service kit includes a rotor hub shim kit. The stainless steel shims come in a variety of thicknesses, each with its own part number. This kit contains 10 stainless steel shims plus 4 Delrin shims. This will give you a variety of sizes so that the exact combination of shims can be chosen. Turn the hub so that the serial number stamped on the hub plate is on the pilot side and the hub is aligned fore and aft to the helicopter. It makes no difference which side of the helicopter the numbers are on, but it's a good practice to establish a normal and routine procedure. Next, index the teeter blocks to the hub and the hub to the shaft. Place the spring scale on the outboard pin and pull up or down until the hub plate starts to move. Read the scale and record the reading for later reference. Measure the hub to shaft center position by using the hub fixture shown. This fixture is easy to fabricate and will give you very accurate results. Reference the maintenance manual for specifications. Place the fixture on the hub. Push the fixture up against the outboard pitch pins and hold the fixture down on the 3 rivet point contacts located on the bottom. Securely hold the fixture on the hub and rock the hub slightly back and forth until the needle on the indicator stops moving in a central position. Then zero the indicator. Carefully remove the fixture and place it on the other side of the hub using the same procedures. Repeat the steps and determine how far the hub is off-center, if any, and which direction it needs to move. Record your measurements. Place the C-clamp across the teeter block so that the clamp jaws clamp at the base and close to the center of the block. Using the 9/16" socket wrench and open-end wrench, remove the locking nut from the bolt. After the nut has been removed and washers taken off, place the box wrench on the teeter block bolts and turn the wrench so that when you tighten the C-clamp slightly, the wrench will begin to move easily. Tighten the clamp down by feel so that you will find the spot the wrench wants to move the easiest. Place a small amount of grease on the bolt threads and drive the bolts out through the hub plate holes. Do not remove the bolts by backing the bolts out with a socket wrench. This will damage the holes in the hub. After the teeter block bolts have been removed, you can now remove the other teeter block bolts and set the hub plate on the counterbalance just below the shaft knuckle. Next, remove the 2 snap rings and the large thin washer from the main drive pin. Deburr the edge of the snap ring grooves and edge of the pin with a 400 to 600 wet and dry sandpaper. With hand pressure and a light tap from a plastic mallet, remove the teeter blocks from the main drive pin. Fabricate a storage unit to keep the orientation of the parts to the hub plate. It is especially important to keep shims in their exact order and orientation. Do not mix the order or orientation of the shims. Inspect the teeter block for any cracks and galling the shims may have caused. Inspect the bearings in the teeter blocks. The recommended changeout on the teeter block bearing is 500 hours. However, if any damage or wear is apparent, they must be changed on condition. Repeat process for the other teeter block. Remove the hub plate, inspect the condition, and clean. Remove the 4 set screws located on the main shaft knuckle. Note there are 2 sets of screws in each hole. Tap the main drive pin out. Remove the drive pin from the shaft knuckle for inspection. Inspect the main drive pin. If any grooves or scratches are present, the pin must be replaced with a new one. Otherwise, it may be used for up to 250 hours, which is the RCO. This main drive pin has been removed at 100 hours. It has marks from the bearings. However, there are no grooves from the stainless steel shims. This main drive pin is okayed for continued use. If you need to replace the shims, find a smooth spot on these parts and measure all shims together with a micrometer and record the measurement. Place the new Delrin shims on both sides of the appropriate stainless steel shim and measure with a micrometer. When replacing the shims, choose shims that will give you the same thickness as measured earlier. Clean the drive pin hole in the outer surface of the shaft knuckle with acetone. Place the hub plate back on the shaft in the correct position according to your earlier marks. Place a thin coat of grease on the outer surface of the shaft knuckle and the drive pin hole. Install the drive pin with the flats facing up. Install only one set screw at this time and slowly tighten to verify the flats are facing up. Then back off slightly. This will prevent the pin from rotating when installing the other parts. Place the steel and Delrin shims on the main drive pin. All shims should have a light coat of grease on each side. Place one teeter block on the main drive pin with the bearings closest to the knuckle. Grease the bolt holes and bolts. Check your identification marks. Align the holes with the hub plate and insert the bolts through the teeter blocks and through the hub plate. Torque these two bolts to 24 foot-pounds. Place the other teeter block on the main drive pin, following the same assembly procedures. Install the drive pin washers and snap rings with the sharp edge of the rings facing out. Replace the clamp on the teeter blocks and tighten slightly. Grease the bolt holes and bolts. Install the bolts through the holes using the clamp to align the holes. Use a plastic hammer to drive the bolts through the holes. If the bolts drive hard, adjust the clamp pressure so that they go with ease. Do not thread the bolts into the hole, as the bolts will gall the aluminum. Torque these two bolts to 24 foot-pounds. Rock the hub back and forth 15 to 20 times to set the shims and grease in their respective positions. Remember, there are 2 set screws to each hole, with the longer one going in first. After assembly, the 2 objectives must be reached. The hub must be on center of the main shaft. The hub pressure must be between 8 to 12 pounds. Note, at times this process is difficult to achieve on the first attempt. Record the poundage of pull required compared to your recorded information before disassembly. If all procedures were done correctly, you should not be any more than 2/1000ths of an inch to 4/1000ths of an inch off center, and hub pressure will still be within tolerance. If all procedures were done correctly, you should not be any more than 2/1000ths of an inch to 4/1000ths of an inch off center, and hub pressure will still be within tolerance. Change the stainless steel shims as necessary, following the procedures as previously outlined. During final assembly of the hub to the main rotor shaft, if you find the allowable tolerance is impossible to achieve, you may lightly sand the Delrin shim with 400 grit wet and dry sandpaper to remove 5/10,000ths to 1/1000th of an inch of material. This final adjustment will allow you to shim the hub within the 1/1000th of an inch total indicator reading on final assembly. Note, the bolts must be torqued to 24 foot-pounds to get accurate measurements. When the hub is correctly centered and hub pressure is within the limits specified, final assemble the hub. The teeter blocks, part number E49-5100, have grease fittings that require a couple shots of Mystic JT6 grease every 25 hours. Keep slowly pumping the gun until the grease flushes through the bearings. The main shaft bearing, part number E49-1220, should be checked for end play at every 100-hour interval. Loosen the bolt on the slider ball ring clamp with 7/16" sockets. Raise the collective to the full up position. Use a flat blade screwdriver to wedge in between the split and the ring and raise the ring up as high as it will go. Mount a magnetic base indicator holder to the steel hood bracket or frame as shown here. Use hose clamps to secure the base to the frame. Position the indicator so its contact point is on the inner steel race of the main bearing. Using a hoist as if performing a static hang check, lift the helicopter and read the dial indicator. The maximum amount of travel allowed is 25 thousandths of an inch. If your measurement is greater than 25 thousandths of an inch, you must replace the main thrust bearing. Reposition the slider ball ring clamp. The slider ball ring clamp is positioned so the lower ears of the collective slider ball stop at 50 thousandths above the inner race of the main shaft bearing. This also serves as a downstop of the collective control. Use a piece of 50 thousandths of an inch aluminum stock to set the proper position of the ring clamp. Place a small amount of grease on slider ball clamp, part number E49-1530, and on the lower ears of the collective slider ball, part number E49-3210. Move the collective up and down several times to ensure grease coats on all related surfaces. The upper main shaft bearing is an on-condition item and should be monitored on pre- and post-flight inspection for condition and temperature. Warning: under no condition attempt to change, alter, modify, or fabricate a main rotor shaft for this helicopter. The slider ball adjustment collar, part number E49-3230, is adjusted and set on a swash plate assembly at the factory. However, it may need to be readjusted occasionally if the helicopter is exposed to severe or radical temperature changes. Level the main shaft of the helicopter by shimming the skids. Using a protractor level, set the swash plate perpendicular to the main shaft by placing the level as shown. Rotating the shaft may help you in achieving the fore and aft angles. Loosen the two set screws, part number E00-9302, and turn the adjustment collar approximately 2 full turns in a counterclockwise direction, loosening the slider ball. With the adjustment collar in this position, cut the wire tie holding the bottom part of the boot to the swash plate. Raise the boot and apply grease to the slider ball and main shaft. Move the collective up and down to work the grease in. Use a product from CRC Industries called Stay Lube Marine Grease. This grease is waterproof and has a high melting point. It also has superior rust and corrosion protection. Replace with a black wire tie. Black weather-resistant ties are recommended for outdoor use. The addition of carbon black provides good ultraviolet protection and prolongs useful life. Now turn the slider ball adjustment collar clockwise until the knurled nut comes to a stop, using finger pressure only. Make a reference mark on the adjustment collar and slider ball, and back off the adjustment collar counterclockwise 1/2 inch. Then tighten the two set screws. If incorrectly adjusted, the slider ball adjustment collar will produce a feedback through the cyclic control. If the adjustment is too tight, the cyclic will want to follow the direction of rotation of the main rotors. If the adjustment is too loose, the pilot will notice cyclic inputs will be slow to respond and sluggish. If feedback in the form of cyclic rotation continues, you may back off the adjustment collar another 1/4 inch for a total of 3/4 inch maximum from starting index mark. If an undesirable condition still exists, contact Rotorway customer service. The use of some silicone sealant on the set screws will help lock the set screw in position and prevent them from backing out. Do not use Loctite. Thoroughly inspect all the parts of the swash plate assembly for wear. To determine if the swash plate scissors need new bushings, Measure the lateral deflection of the rotating swash blade with relation to the scissor and counterbalance. Normal movement should be between 1/16 and 1/8 of an inch lateral deflection. If the deflection is greater than 1/8 of an inch, then disassembly and further inspection is required. The scissors use short nylon bushings. The counterbalance and scissors clevis use long nylon bushings. Between the contact surfaces of the swash plate scissors and the counterbalance and scissors clevis are Delrin washers. Inspect the bushings, washers, and bolts for wear and replace if necessary. After replacing any nylon bushings, check the fit of the bolt. It may be necessary to use a reamer in the nylon bushings to achieve the proper fit of the bolt. The bolt should not bind in the bushings. You should be able to turn the bolt with your fingers. Use a film of grease on the bolt and both sides of the Delrin washers upon final installation. When replacing the Delrin washers, it may be necessary to sand them slightly with 400 grit sandpaper to achieve the proper fit. Caution: upon reinstallation of the parts, do not over-tighten the assembly. This will cause vibration throughout the rotor system, as demonstrated in this test assembly. Follow this rule as a guide when tightening the castellated nuts. The maximum the castellated nut can be tightened down is 2 flats after the nut can be turned tight by your fingers. Further tightening may damage the aluminum castings and can cause feedback through the cyclic. Check the proper amount of lateral movement between the cyclic cable mount, scissors, and non-rotating swash plate. Inspect for cracks at the base of the 90-degree bends on the collective scissors mount, part number E49-1380. Install the blades. Refer to the main rotor rigging section in the construction manual and video for correct rigging procedures. After performing the 100-hour service on your helicopter, it is a good and safe practice to perform an inspection similar to the new aircraft inspection. Using the same checklist to verify and check all the alignments and riggings will allow you to double-check everything. It is also a good practice to tie the helicopter down for its first run-ups after servicing the main rotor blades, hub, and swash plate. This concludes the 100-hour inspection and service interval. Remember to combine the 25 and 50-hour inspections and service with the 100-hour interval.